Hello again, grade 9. So in this lesson or in this video, we're going to be looking at Newton and his laws. This is on page 6, right underneath unbalanced forces. And there are 3 laws that you need to know. Those of you that are going to be carrying on with science, I want you to pay special attention to this section because in grade 11 and more so grade 11, we go into a lot more detail when it comes to Newton and his laws, and you need to pay attention now. So if you get a good foundation now, it's going to help you out later. Right. Okay, so the first law that we're going to look at is Newton's first law, and this is the law of inertia. And in the previous lesson, we went into what inertia is and how it's a tendency to resist any sort of change. There's 2 pictures here. There's a picture of a soccer ball and there's a picture of a penguin that is sliding down a snow slope. And both of these pictures show exactly what's going show Newton's first law. So an object at rest will remain at rest. The same as if an object is moving at a constant velocity, it's going to stay at that constant velocity until there is a change in the forces. If the forces are no longer balanced, there's going to be a change. And with that change, okay, right, there will be inertia because inertia is going to resist that change. Okay, it wants to stay the same. And the same with our little penguin that is moving down the slope. He's moving down quite happy, he's quite chill, but then he hits a rock, so he's no longer moving. It's just a little funny joke to show how the first law works. So you should know this by now. This law you should be super comfortable with. It relates directly to unbalanced forces. So I want you to link these 2 together. Maybe make a note for yourself somewhere on the page. So Newton's second law has got to do with the law of acceleration. Now, here we go. You've got a new formula. You're learning a new formula now. Remember, we spoke about net force. We spoke about resultant force. The resultant force of that is left behind, what you're left with, is the product of the mass multiplied by the acceleration. So this formula is going to give you your net force, and that's what it's got to do with. It's got to do with the law of acceleration. And it's saying that, according to Newton, an object will only accelerate if there is a net or unbalanced force. So again, relating to unbalanced forces. It's not going to accelerate. It's not going to change in speed. It's not going to slow down unless there's an unbalanced force. The presence of an unbalanced force will accelerate the object. Now, when we use the word accelerate in physics, it actually means to slow down or to speed up, just by the way. So it changes the speed, its direction, or both its speed and direction. Okay, so if we apply more force, it's going to accelerate at a higher or at a higher rate. So please write down this formula, and you can make it as F net is equal to MA. F net is equal to MA, but there'll be a chance for you to fill this in a little bit later in the lesson. The last law that you need to know about is called the law of reaction. This is Newton 3. Now, what this dictates is that for every action, there is a opposite but equal. So it's opposite but equal reaction. Forces operate in pairs. You might not feel it. You might not even be able to notice what's going on, but there's always going to be an opposite reaction. If you lean against the wall is leaning against you, guys. You don't even know that it's happening. Look at the balloon over here, okay? Right? It's showing for every action there's an equal and opposite reaction. Okay, so what's happening? The air is escaping. The escaping air pressure forces the balloon forward. Okay, the elasticity of the balloon forces air out of the balloon. So you've got 2 separate directions, but the magnitude is the same. Look at the ball hitting the surface of a floor or wherever that could be outside on the lawn. The ball is hitting the surface at a certain angle, at a certain direction, and then afterwards it is going to move in another direction. The magnitude is still there, but there is an opposite direction. That is the most important thing I want you to remember, guys, is that these work, it's exactly the same, it's equal, but they are opposites. Okay, we're going to go into a little bit more detail regarding this a little bit later. For now, this is all you need to know. At the top of page 7 of your notes, you will see there's a little section on Newton 1, 2, and 3. I want you to fill this in. It's just a summary of exactly what we've just spoken about. So the three basic points are, for Newton 1, objects will remain at rest or at a constant velocity unless an unbalanced force acts on them. This is the law. This law relates to inertia because the object does not want to move, or the object does not want to change in velocity. Lesson 2, when unbalanced forces acted on objects, the objects will move or accelerate, that means either slow down or speed up, as a result of the unbalanced force. And then Newton 3 is all forces act in pairs. Please fill this in, and then we're going to carry on with our formula and a few examples. In all of these examples and all this discussion that we've had, it's all got to do with resultant force. It's all got to do with an object in motion and what is the force that we're left with. Okay, so we call this Fnet, or net force, resultant force. We spoke about it before. I've said this before in unbalanced forces. So you guys should be super comfortable with this. Please write the formula in. Fnet is equal to ma, mass times acceleration. Mass is in kilograms, acceleration is meters per second. Please write all of these in your little box there on page 7. We are now going to go through 3 examples in the let's practice a few calculations, and then we will be finished for today. Okay, so as you have never done this by yourself, I'm going to show you exactly the layouts and how we expect you to work out these problems, grade 9s. So at the bottom of page 7, you will see there's a few practice calculations. Let's look at the first one. Now, don't just write these down. I want you to listen to me and work with me step by step, because you miss a step, you're going to miss marks. Remember, show your working out, show your work, show me where you did what you, how you figured the problem out. I need evidence, otherwise I can't give you the marks. Question 1 says, determine the accelerations that result when a 12 Newton net force is applied to a 4 kilogram object and then to a 6 kilogram object. Okay, so what we've got here is we've got our Fnet, but we've got 2 different masses. Therefore, to work out our accelerations, we are going to have 2 separate calculations. The first one is using 4 kilograms and the second one is using 6 kilograms. So you need to underline that for me. I want you to actually make it very clear. This is 4, this is 6. Show the difference in on your actual page. First thing you're going to do is give me the formula. Okay, I want Fnet equals MA. Then I want you to put in the substitution. Okay, and you're not going to get 2 marks for substitution or manipulating the formula. You're going to get 1 mark for that. Okay, and then you've got your final answer, which is going to be for 4 kilograms, it will be 3 meters per second, and for 6 kilograms, it's going to be 2 meters per second. So, which is going to be faster? It's going to be the 6 kilogram one. Okay, so please make sure that you write this in, and you can even draw the text in for yourself, so you know exactly how we want you to structure it, how we want you to lay it out for us. Okay. Question 2 asks, a net force of 15 newtons is exerted on an adorable piglet to cause it to accelerate at a rate of 5 meters per second. Determine the mass of the piglet. Once again, this is not asking a direct question on Fnet. It's asking something different. Now, the previous question we asked acceleration. Now we want mass. So, grade 9s, what have I always said to you? I want you to, on the side, like maybe make a line for yourself. put in everything you have. You've got your net force. You have your acceleration. What is the thing that I'm looking for? I'm looking for my mass. So let's plug and play, because that's all it is here. It's very, very simple. You're going to say Fnet equals MA. Automatically you get a mark. If you know nothing else, you automatically a mark just for formula. Then you're going to actually put in these, manipulate the formula. 15 divided by 5, you are going to get 3 kilograms. Remember what I said to you before? Please put in the unit. If you don't put the unit in, I'm minusing a mark. Okay, so like I said, pause the video if you haven't written this in yet, or if you have, then we go on to the last question. Okay, so question 3 is a comparative question. So there are 2 separate problems, and they're asking you, what is the greater acceleration? So grade 9s, when you get a little bit of a complicated question, always ask yourself, what do they want? What do they want? What does BAM want? Right, in this situation, I want to know what is the greater acceleration. That is, at the end of the day, that is going to be your answer. But you need to prove to me that you know what the greater acceleration is. So the first one, A, is a net force of 20 newtons acting on a 6 kilogram object, and B is a net force of 30 newtons acting on a 7 kilogram object. So we've got net force here, we've got mass, we don't have acceleration. So what am I doing? I'm putting here on the side what I have and what I don't have. So exactly like we did before, you're putting exactly what you have and what you don't have. What don't you have? You don't have acceleration. So please write that in on the side, on the left-hand side. That's the first thing you do. Under A, you plug and play. So it is going to be formula. You manipulate the formula. 20 divided by 6 is 3.33 meters per second. Formula, manipulate the formula, substitute. 30 divided by 7 is 4.29 meters per second. So, but now you've shown me all the working out, which is fantastic. I'm very happy. But what is the last thing you have to do? You need to actually tell me, give me my answer. What is my answer? My answer is that B will experience a greater acceleration. Believe it or not, you get a mark for that. So please include that. All right. We are done with lesson 2 now. We're done with the section. The next section we're going to focus on is going to be on work. Yes, that is it. Work is going to be the next thing that we do. But for now, I want you to make sure that you understand this understand this carefully, understand every bit of the steps. Understand that you need to prove your answer to me, because by proving your answer to me, I know that you understand the work. If you still are struggling or you're worried, please drop me a message, or please attend the tutorial, which will be in week 2 of term 2. Have a good day, grade 9s, and we'll chat soon.